So welcome to this fourth webinar of the Arqus workshop on AI teaching and learning, international perspective and best practices. The agenda for today is that we're going to have two speakers. We apologize, but one of the speakers, Cédric, couldn't be present today. And we are going to have, as I said, two speakers, and they will give some presentation during the next 10 minutes each of the speaker. And at the end of the speaker time, we will have the breakout rooms. Breakout rooms will be held around 15 minutes per round. We're going to have two breakout rooms, meaning that it's going to be 2 rounds of 2 breakout rooms. So today's webinar will only last a maximum of 1 hour instead of the 1 hour and a half that we forecasted. Thank you for your understanding. So maybe you already participated to these webinars. In this case, if not, please take advantage of the assistance of Mandis Trambowski and Mirko Fecchio from Padova and from Leipzig, which are my colleagues in the Arqus VG5, Working Group 5, talking about learning innovation. So today's presenters are, first of all, Augustas Vaitkevičius. I'm sorry if I pronounced it wrong. I was almost there, right? He's a physicist and lecturer at Vilnius University. He teaches computer literacy, focusing on programming and AI literacy for physicists, combining both hands-on technical skills with critical reflection on AI tools, ethics, and academic practices. His thesis emphasizes practical use, transparency, and student autonomy. Our second speaker is actually 2 speakers from Padova University. I'd like to introduce Giulia Mormando, which is an emergency medicine consultant, PhD, and researcher at the Department of Medicine at the University of Padova. She's responsible for the training in simulation for the emergency medicine residency program. She's fully trained as a trainer and facilitator in simulation, and currently she serves as secretary of the Italian Society of Simulation in Medicine. She collaborates in several national and international centers on this topic. The second speaker from Padova for the same presentation is Dr. Rebecca Zini, which graduated at the University of Padova in 2019. In 2021, she began her training as an assistant and emergency resident, joining the medical simulation facility in her second year. Her field of interest is AI facilitated medical simulation, CRM, and non-technical skills training. So we are going to follow these 2 presentations, 10 minutes each, in a few minutes. And after that, we're going to meet each other all together to move you into the breakout rooms. Breakout rooms will last 10-15 minutes. During the breakout rooms, you can choose one of the speakers you heard to make questions, pick up answers, and go through deep technical details of their presentation. So please take in mind that we are not accepting questions or neither in direct video questions nor in the chat room during the presentation that we are going to hold in the next 20 minutes. Please keep mind of your question for the breakout rooms. I think if everything is clear, I will just move to the first presentation and leave the floor to Augustas. Thank you.
So thank you for the nice introduction. I will try to share my screen. And okay, can you see the slides?
Yes.
Okay, so let me begin. As previously mentioned, I am Dr. Augustas Vaitkevičius from Vilnius University, and I will talk about teaching generative AI through direct tool integration. So the agenda for this short presentation is first I will discuss the motivation for doing this, what I'm trying to achieve with this teaching, and our target group, and then a quite detailed description of the implementation, what we do with the students. Okay, so the main motivation behind this is that students are very much, everyone is using LLMs like ChatGPT, Bing, Gemini, whatever, and they are kind of treating it like Oracle on a hill. That's a special black box that gives you answers. They are not approaching it critically. Some students have heard about AI hallucinations, but very few. And what I want to show is that these large language models are computational systems. They are controllable. They have parameters that can be set and adjusted and so on. They are very easily interacted with using simple Python programming. And even though they are controllable, they are still non-deterministic. So the behavior of these systems has to be interpreted very carefully. Right. So the target group that I'm working with are bachelor students, first-year physics students in the autumn semester. So it's their very first introduction to university. And I work with them in small groups, in practice sessions, teaching them computer literacy. That's a more general course about Word, like simple Microsoft software, simple data analysis software, LaTeX, and like half of the semester is about Python programming, very basic introduction. And during that part, I spend 1 week demonstrating this LLM integration, because most students, well, I think 99% of the students have used LLMs, but through informal and less rigorous modes. The main tool I use is, of course, Python programming language and a software called Ollama. It's free, it's very easy to use, and everything we need is a computer from the teaching laboratory or student laptops are enough. Python and Ollama has to be installed. Ollama allows us to use these low memory, simple, open source language models. They are worse than ChatGPT because those kinds of models like ChatGPT, DeepSeek, Leshat, whatever, they use very large computer resources. Here we are working with small student computers, but we are not reliant on external services. It's, as I mentioned, free, very accessible, and easy to modify. So implementation is 90-minute practical sessions, 1.5 hours. Students get some simple instructions, some simple code that they modify to locally execute these large language models. As I mentioned, they are integrated. This course is integrated in basic Python programming, but they don't need any machine learning instruction, any statistics or anything like that. So they only need to already have some basic Python knowledge, so like variables, control flow, basic functions, simple data structures, but very, very basic. I want to stress that the exercises we do are really easy. This is the piece of code that we give our students, the very initial bit. So the only 10 lines. The first line is importing specific libraries that interact with the LLM. And then we use that to create prompts using programming. So, for example, this is a very basic question. We act as a user, as we often are, and ask, why is the sky blue? So everyone knows, I think, that these commercial LLMs have a master prompt, a system prompt that's hidden, and we do not know what it is. We only know that it's very big, very detailed, and gives a lot of hidden instructions to the model. So we can modify. We can also set in this use case, the system prompt, we can modify it, and similar to what is typically hidden from us, here it's explicit, and we can change it to what we need. So it's a good illustration of what happens when we use ChatGPT, but in this case, we control it. And because we are using Python, we are not having to use multiple browser tabs to ask the same question multiple times to check for consistency, or to test changing the prompt text manually. We can do it pragmatically using programming. Here, for example, I am giving the model question, the same question, why is the sky blue? But changing the system prompt to require the answer to be in 1, 2, 3, or 4 sentences. And here are the answers. It's next to instantaneous because the question is very easy, the model is very small, and even on my simple regular computer, it's a very quick computation. And we can see that the answer is increasing in length as we asked, but the number of sentences is maybe not that accurate because counting is hard. Right, we can also modify the question using Python. Very simply, here we have a similar structure, but this time we are asking if the sky is black, if the sky is blue, if the sky is why is the sky green, red, and black again. And we get these answers. So Python-wise, it's a very simple implementation, but we already see that the answer is not the same each time we ask why is the sky black. That is because LLMs have a parameter called temperature, as I'm sure most of you know. It determines how much variability is in the answer. And this is also something we can control. Very simply, here we have a snippet of Python code where each question is asked multiple times, 3 times, and with different temperatures, ranging from 0.1 to 0.9. So students are able to write this kind of code themselves, and then they get, in a few minutes, a result like this, where predictably, when the temperature is set low, the answers are the same. When the temperature is increasing, the answers get more varied. Another concept that's often discussed in the context of LLMs are tokens. So this is also something that's easy to do, easy to demonstrate using Olama, that these token counts for the prompt, token counts for the response, very easy to visualize. And when students vary the prompt and they check if the length is increasing, if the response token counts are increasing or decreasing with temperature in this example, but over those 90 minutes, many different examples are ran. So here we see that it appears with low temperature, response tokens are generally lower. With increasing temperature, they increase, but not monotonically. With very high temperature, it's more varied. Seems like a good result. It's illustrated to students that there's more than one way to look at an answer proposed by ChatGPT. Right, and after this, students then go on to do long-term projects, around a month of independent work in groups, where they create these Pythonic AI agents. They use this the knowledge they get during the course to create a program that interacts with a data set or implements AI-based control flow. And those projects are very varied, very creative. Each time I'm very impressed with what our students come up with. Right, so to conclude, generative AI can be introduced effectively through direct integration with existing programming knowledge, and treating LLMs as controllable computational systems promotes critical engagement rather than passive use. And thank you.
Thanks a lot, Augustas. Now I will leave the floor to Julia and Rebecca.
Okay, you see the
Yes, we
slide?
see
Okay,
slide
thank you.
and we hear you correctly. Thank you.
Perfect. So thank you for the introduction. I'm very happy to be a part of this Arqus webinar and to share our experience in using AI to support clinical training in medical education. One of the key challenges in medical education is providing students with enough opportunities to practice clinical skills in a consistent and safe way. So, amongst these, taking a patient's history or anamnesis is fundamental, but difficult to train systematically due to limited patient access, time constraint, and variability in clinical exposure. That's why we decide to use AI-powered simulation. Allows to offer scalable and on-demand practice. So students can interact with the virtual patients, repeat the exercise as often as needed, and receive the structured feedback immediately after. And this helps close the gap between what they learn in the classroom and what they need to apply at the bedside. The learning objective of our AI-based lesson are clear. We want students to practice anamnesis in a realistic setting, to apply clinical reasoning and structure question techniques, to improve their communication, and to reflect on their performance using AI-generated insights. This way, there are not only learning what to ask, but also how to ask and why it's matter. And now a few words about our target group. Our focus is on clinical medical students from fourth to sixth year of their studies. These students usually work in a cohorts of 80 to 100 students, and are already familiar with the theoretical framework of clinical reasoning, but often lack opportunities to practice in real clinical setting.
Okay, thank you, Julia. And now I'll guide you guys through the project. And before we start, I'm not sure everybody is familiar with the high fidelity training. So just to make sure we share a common ground, what it's typically done when we start training students to take a history is either we encourage them to role play with each other, which is certainly useful, but exposes the student to the shortcomings of reproducing case scenario they're yet not familiar with. And the other way that is usually done is by taking the students into the high fidelity simulation rooms where they get to interact with a high fidelity trainer, which is usually a mannequin that the instructor controls through a microphone. So the student talk to the mannequin, but they're actually talking to us, and we provide the case scenario, we role play the patient, we respond to their questions, and this might seem an easy way to do it, but in reality it often becomes quite difficult and challenging for the trainer, because at the same time you will need to be, actually keeping an eye on so many aspects of the clinical experience, like, the vitals that you're going to show and how those vitals are going to change depending on what the students are doing. And there is also a matter of, technology, because you're basically talking to each other across separate rooms. So sometimes microphones don't allow you to really get what the students are saying because of the distance. And that's why we came out with the idea of creating a mannequin that could incorporate the ability to understand what the students were asking to it, to elaborate an answer that, using AI possibilities, might mimic as much as possible the answer the student would get in real life when approaching a patient for the first time during clinical rotations. So the project started back in a couple of years ago, and this is a short model on how it's done. So we set up the students in a room with a microphone that connected to the mannequin, and the microphone recorded the voices of the student. A speech-to-text module translated it into a written test that was then analyzed by chatbots, and that provided an output text answering the student inputs, which was then translated back to voice. Good experience, but it encounters some of the shortcomings that have also been, somehow anticipating in the lecture that came before us, because this first experience was built on untrained large language models, which, of course, they provide answers, but they tend to get their answers, their knowledge, from a large set of data which are not selected, are not checked. And so the answers, what we got is that the veridicity of the scenario, the inner coherence of the speech tended to fade quite away. So in the end, what we had was a sort of babbling machine, hallucinating machine. And of course, another shortcoming that we faced was the quite a long latency, recording the voices and then translating the speech to text and then the text to AE from outputs and then the outputs back to voice, which somehow tended to diminish the veridicity of the whole experience. So what came in help and is and these represent the enhancements we are actually working on, is that, as said before, now what we are learning so far is that you can, train your AI to get their answers, run their answers, not on a vast large of data, but on smallest, data and sets that you control. And this can be done in various ways. You can get your custom GPT, custom AI by providing a small data set, and this is especially useful when we are, training the students. Like in this case, we're working on specific subjects like topics like chest pain, or through APIs you can connect your chatbots to, larger data center that data groups that are still, checked regularly and updated regularly. And I'm sure you've heard some of them, like open evidence or up-to-date are two large data groups that are used quite frequently in medicine. Also, to reduce the problem of latency is and help is coming more and more from agentic AI. As you know, the agentic AI, the next generation are becoming more and more skilled in completing complex tasks by interfacing themselves with other AIs that might provide them the tools that they need to provide a more realistic experience, and that comes from controlling the quality of the voice, controlling the quality of the conversation, controlling the tone and the emotion of the conversation. And we're also working on diversification of products. I mean, nowadays, bringing students into a highly technologically environment, which is the simulation room, is still quite time consuming, both for the trainer and the students, because they have to come. And the reality is that we are getting there have been some changes, organizational changes in the way students are being selected for the medical training. So our experience is that we're facing larger and larger group of students, and so we are also trying to use these chatbots to provide online tools that students can start to access and interface even from a laptop from home. In this case scenario, to start that training, get the training going, get the knowledge going before actually going into the emergency room, where they will have maybe 2 or 3 minutes to take an accurate history that will in the way determine all the exams, all the course of action that will be taken on the patient. So just technical inconvenience. Oh, sorry. So our purpose for the future is to create a machine that could interact effectively and in a less time consuming and effort consuming way with the students, helping them tune their history taking skills while avoiding the shortcomings that come from overloading the trainers with several tasks of controlling the mannequin, the vitals, but also to paying attention to what is going on in the room and actually allowing the trainer to be the observer and the guide to the students, and not just the technical assistant of the mannequins. And thank you.
Thanks a lot. Very interesting. Thank you, both speakers. So now we technically move to the breakout rooms, where you will have the possibility to talk directly with with the speakers of today. We're going to open 2 breakout rooms, one for Julia and Rebecca, and the other one for Augustas. So please choose your room. Remember that after 15 minutes, you will be taken out again in the main room to choose the second.